let's look at what happens when we need to sketch radical functions. Now, radical functions tend to have something wonky in them, but we follow the exact same steps. So, for y is x over x squared plus 2, the first thing you need to do is take the first derivative, and of course the first derivative is 2 f prime is equal to 2 divided by x squared plus 2 to the 3 halves. The next thing you need to do is take the second derivative. So we take the derivative of the first derivative. And the second derivative in this case is minus 6x divided by x squared plus 2 to the 5 halves. Now you need to find the x-intercepts. All right, the x-intercepts, where does it cross the x-axis? And the only place this occurs is at x equals 0. And the y-intercepts, in this case, it also occurs only at x equals 0. Do we have any vertical asymptotes? Is there any way the denominator can be 0? And the answer is no. There's no way the denominator can equal 0, so we don't have any vertical asymptotes. Do we have any horizontal asymptotes? Well, let's look at the limit as x goes to infinity. As x approaches positive infinity of x over the square root of x squared plus 2, and we'll see that this is positive 1. So the first horizontal asymptote is y equals plus 1, but whenever you have a square root like this, we now need to look at what happens to the limit as x approaches negative infinity, and that is x over the square root of x squared plus 2. This is going to be negative, and this is going to be positive, but it's going to go to negative 1. So it's going to be y equals plus 1 and y equals minus 1. So you're going to want to put in your horizontal asymptotes here of y is 1 and y is negative 1. And of course you will have wanted to put in your intercepting point 0, 0. So the end behavior is it's going to approach this asymptotic behavior. It's going to approach plus 1 and negative 1. So what are the critical numbers? Where is f prime equal to 0? Well, f prime does not ever equal 0. So we have none. All right, let's look at the possible inflection points. Where would this possibly change sign? Well, the only place f double prime can change sign is at this, let's see, let me change this to green. F double prime equals 0. It can change sign when, well, it's equal to 0 when x is 0. So when x is less 0, this number right here is positive, so f double prime is positive, so it's concave up. And when x is less than 0, f double prime is, when f double prime is when x is positive, f double prime is negative, so it's concave down. This almost gives us enough information to tell us it's going to go up. It doesn't have any maxes or mins. From 0 to infinity, it's concave down, and from negative infinity to 0, it's concave up. Now let's see if I got this right. The first derivative in this case is always positive. All right, I said the first derivative couldn't be 0, but the first derivative is always positive, so it's always increasing. So this is what my function looks like.